You can almost picture the scene. A lawyer standing in a courtroom, feeling confident, maybe even a little cutting edge. He decides to use AI to assist with his arguments during a live hearing. And it's an absolute disaster, a total failure. The immediate reaction, the one you hear in the media and in casual conversation, is predictable. See? This technology is making us lazy. We're stopping to think for ourselves.
That predictable panic is the most fascinating part of the story, isn't it?
It is. That situation didn't collapse because the technology is inherently bad. It collapsed because the human failed to apply strategy, ethics, and accountability to the tool. But what's truly interesting isn't the failure of the lawyer. It's the failure of that conclusion, that AI makes us cognitively lazy. This panic, this narrative that we're outsourcing our brains and becoming intellectually weaker, feels incredibly familiar. It's the exact same tune we heard when the calculator became common, and the same one we heard when Google arrived and digitized all information.
And that historical familiarity is precisely what we need to challenge in this deep dive. When we look at history, the fear that new technology will make us intellectually weak is constant, yet the outcome is almost universally amplification, not annihilation. This moment we are living through, however, is fundamentally different from those earlier shifts.
How so? We talk about the Industrial Revolution, which gave us mechanized looms and steam engines.
Well, the Industrial Revolution primarily augmented physical muscle power. It made us faster, stronger, more capable of repetitive manual labor. This shift, it's not about the body, it is a cognitive revolution. It was about augmenting the mind, thinking, reasoning, analysis, and creation. We are building the foundational infrastructure for, well, thinking faster and generating knowledge at a previously unthinkable pace.
A steam engine of the mind. I like that because it implies power and scale that goes far beyond a simple calculator.
Exactly. And because the fundamental nature of cognitive labor is shifting, it demands not just the acquisition of new skills, but the active, difficult process of discarding outdated professional instincts and mental models.
Right.
The mission for this deep dive is clear. We must analyze the empirical evidence that establishes AI as a true, measurable productivity engine, and then define those critical new cognitive skills, the challenging processes of unlearning and relearning, required to not just survive, but truly thrive in this new era of knowledge work.
Okay, let's start by reframing this technology in human history to truly grasp the scale of the cognitive revolution. The Industrial Revolution focused on material output, but when we talk about large language models and generative AI, we are talking about something qualitatively different. We aren't just building a faster loom, we're building, like you said, an auxiliary brain capable of synthesis.
That's the core insight. To understand the magnitude of AI, we shouldn't look at the machines of the 18th century, but at the foundational intellectual leaps of human civilization. The first great cognitive revolution was arguably the development of writing systems in ancient civilizations, like Sumer in Egypt.
Writing systems, right? They allowed humans to externalize memory.
Precisely. Before writing, knowledge was confined to the internal memory of a generation, transmitted orally. Writing broke that barrier. It allowed humans to externalize complex information across time and space, enabling the accumulation of cumulative, ever-growing knowledge structures, the basis of modern science and bureaucracy. This dramatically boosted cognitive productivity because the mind was freed from, just rote retention.
And even that revolutionary step was met with skepticism, wasn't it? I seem to recall reading something about that.
Absolutely. It provides a striking parallel to today's panic. Plato's dialogues recount Socrates worrying intensely that writing would annihilate our memory because people would stop relying on the internal, active practice of recollection. He feared the introduction of a prosthetic memory would lead to intellectual weakness.
Sounds familiar.
It does, doesn't it? But far from diminishing us, literacy vastly amplified human intellect and capability. AI is the modern accelerated parallel. Just as writing externalized memory, AI externalizes certain reasoning and complex problem-solving processes. It is a profound tool for cognitive offloading.
Okay, so if writing was the first leap, what was the second major step in democratizing and amplifying intellectual spread?
That would be the printing press in the 15th century. Gutenberg's movable type press didn't just store information. It democratized its spread and lowered the cost of intellectual labor drastically, triggering the Renaissance and the scientific revolution.
Right, making knowledge accessible on a whole new scale.
Exactly. A Brookings Institution report put it perfectly. If the printing press released ideas and information from captivity, AI now accelerates their analysis to produce conclusions that extend the boundaries of knowledge. AI accelerates cognition itself. It doesn't just store knowledge or spread it. It can actively analyze, synthesize, and generate new knowledge or drafts on our behalf.
So if the calculator externalized arithmetic and Google externalized search, AI is externalizing reasoning and synthesis. And this realization brings us to the crucial definition. We can't just call AI a general-purpose technology, like electricity or the internet. It feels bigger than that.
No, that's inadequate. We should think of it as a general-purpose cognitive technology.
Cognitive technology, okay.
Yeah, previous general-purpose technologies, such as the steam engine or even electricity in its early days, were initially confined to specific industries: manufacturing, transportation, communications infrastructure. Their impact scaled over decades. AI's general ability to handle language, symbolic manipulation, pattern recognition, and complex knowledge means its core impact applies instantly across virtually all sectors of cognitive labor, from law and medicine to design, writing, and software development.
No.
It's ubiquitous from the outset, which is why the transition feels so fast.
That instant speed and scale are terrifying to some, but at others, they are the promise of unprecedented productivity gains. Let's move from theory to concrete, high-impact examples that show AI is measurably boosting cognitive tasks with speed and accuracy. Where are we seeing this cognitive augmentation in action right now?
One of the most stark examples is in the legal field, a domain historically centered on immense amounts of detailed, high-stakes knowledge work. Think about the exhaustive process of contract review,
Which requires unwavering attention to minute detail, consistency, and an ability to hold complex legal concepts in one's head while sifting through hundreds of pages. That sounds like a perfect job for a machine, but one where human fatigue is a massive factor.
Precisely. Consider the benchmark test in legal automation. An AI system was tested against 20 experienced corporate lawyers in reviewing complex legal contracts, specifically non-disclosure agreements, looking for risks, issues, and specific clauses.
The numbers that came out of that study were a genuine shockwave for the legal world, weren't they?
They were. The AI system demonstrated 94% accuracy, effectively matching the best human lawyer in the entire group. But the real story is the time required. The AI completed the task in only 26 seconds.
26 seconds.
Compared to the human lawyers who, on average, took 92 minutes. Now, let's analyze the professional implication of that.
Wait, I have to ask, though. Doesn't the 94% accuracy mean the human lawyer still needs to spend time verifying the remaining 6% of the output? Does the speed really translate to a zero-sum gain if you still have to check its work?
That's a critical question. And the answer is that the nature of the remaining cognitive load fundamentally changes. The human is no longer tasked with the crushing mental fatigue of seeking the needle in the haystack 100% of the time.
Okay.
They're now tasked with verifying a high-probability result and focusing their high-value judgment only on the marginal complex cases the AI flagged as uncertain, or maybe the 6% it potentially missed. Shifting from 92 minutes of high-detail execution to perhaps 10 minutes of critical oversight, well, that's a shift in the order of magnitude. It means a legal department can handle 10 times the volume without sacrificing quality.
That's a dramatic efficiency gain. And we see similar leaps in even higher stakes fields like medicine, where human diagnostic judgment is paramount.
Absolutely. In healthcare diagnostics, AI models are rapidly augmenting and sometimes rivaling human expertise. Consider a deep convolutional neural network model trained on, I think it was 129,000 skin lesion images. This system was found to diagnose skin cancer with dermatologist-level accuracy.
That's impressive. But a panel of dermatologists represents decades of cumulative, specialized human knowledge.
And yet, in one controlled test, the AI model slightly outperformed a panel of 21 certified dermatologists in accurately identifying malignant lesions during initial screenings. The key here is not that the AI replaces the doctor. It doesn't. But that it acts as a force multiplier.
Ah, okay.
It provides a level of speed and consistency in initial image screenings that dramatically improves the workflow, allowing the human expert to focus on complex, ambiguous, or rare cases.
It seems like the common thread here across all these examples is the ability to process data at a volume and speed that is simply impossible for humans. It's the sheer scale of computation that defines this cognitive augmentation.
That is the definition of the advantage. You see it most dramatically in scientific discovery where the volume is astronomical.
Yeah.
A human researcher cannot manually screen hundreds of millions of compounds. It's just not feasible. But an AI system can. Take the discovery of the antibiotic Halicin back in 2020. Researchers used a deep learning model to screen over 100 million chemical compounds in a matter of days. The AI identified Halicin, a novel molecule effective against highly resistant bacteria, a feat that was previously completely infeasible for manual lab work. These examples demonstrate that AI is not a hypothetical future threat. It is an active, measurable engine of cognitive productivity, accelerating every field it touches.
Okay, so if AI is the new engine generating all this speed and volume, then the professional human workforce needs a new operating manual. This is where we pivot from capability to psychology, bringing us back to that famous prophetic statement by futurist Alvin Toffler.
That's right. The illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. We must focus deeply on that middle verb, unlearning. It's the pivot point between being automated and being augmented.
It sounds so simple, almost like forgetting, but you're suggesting it is deeply challenging and active.
It is a profound psychological and professional challenge because it requires the professional to relinquish the expertise that previously guaranteed their status and income. Unlearning is defined as the conscious, active process of questioning and abandoning mental models, habits, or ingrained processes that are no longer effective or relevant in the new environment.
So it's not about losing old knowledge.
No, it's not about losing old knowledge. It's about choosing a new, better paradigm for applying that knowledge.
So why is this so hard? I imagine most people want to be more productive.
Well, the difficulty arises because professionals often build deep psychological defenses around their expertise, what we call knowledge shields.
I love that terminology, knowledge shields. It speaks to both protection and resistance.
They are powerful defenses. These are beliefs and models developed through years of experience that provide a rough, comfortable approximation of reality. They give the professional confidence, mastery, and a sense of irreplaceable value. Think about the lawyer in our opening anecdote. His knowledge shield told him his traditional research process was the only reliable one.
Right, the tried and true method.
Exactly. But when faced with contradictory information, like an AI system performing their core task faster, or the necessity of cross-disciplinary skills, there's a natural, intense reluctance to discard those shields. The professional has to fight the tendency to rationalize away the new reality by saying, oh, the machine's results are cheap, or, well, this doesn't apply to my specific context.
To make this internal psychological struggle relatable, let's look at how this plays out in a creative profession where value has historically been tied directly to manual effort, time spent, and proprietary craftsmanship. This is the purest form of the effort equals value mental model.
That's a perfect scenario to explore the psychological shift, because AI challenges the very definition of creativity in these fields.
Yeah, I came across an anecdote about a senior graphic designer, we'll call him Kenji, working in Tokyo. He had built his entire 20-year career on his painstaking mastery of layout, typography, and manual creation tools. He viewed the new generative AI tools as a gimmick, a cheap trick for those without real skill. His professional identity was wrapped up in being a meticulous craftsman. He was proud of his process.
That pride, that shield, is exactly the bottleneck.
Exactly. His firm took on a massive rebranding project. Kenji, using his trusted, painstaking manual process, spent 2 days meticulously crafting 3 distinct, polished logo concepts. Meanwhile, he watched a junior designer, barely 2 years out of school, use an AI tool not to finish the job, but to rapidly prototype. She generated 50 concepts in an afternoon. 50. She then spent her time curating, refining, and applying human taste and strategic reasoning to the top 5 designs. When the client praised the variety and the speed of the junior's curated work, Kenji felt a sudden cold dread. He realized his mastery of the old, slow process was now actively a bottleneck to productivity.
Kenji's story perfectly illustrates the collision between the industrial age mental model, the clock-in, clock-out effort model, and the cognitive revolution. For Kenji, the painful, active process was letting go of the idea that effort equals quality.
Yeah.
The machine had automated the routine execution of drafts, concepts, and layouts. The value of his time instantly shifted from manual creation to strategic oversight. He had to unlearn being a meticulous craftsman to relearn being a strategic creative director, focusing his time entirely on client communication, aesthetic curation, and ethical judgment. That's often the hardest part of the transition for high-performing professionals.
Okay, so once you successfully unlearn the old time-bound model, you must relearn the new skills that effectively leverage the speed of the AI engine. If AI is the engine, the instruction, the prompt is the key input that directs its incredible power. This leads us straight to advanced prompt engineering.
Prompt engineering has rapidly emerged from a niche technical idea to an absolutely essential capability for virtually any knowledge worker. It's no longer about typing a simple query into a search bar. It is the art and science of designing instructions that strategically guide large language models, LLMs, to produce optimal, predictable, and useful outputs. We are moving from being passive users of technology to being strategic directors of cognitive systems.
Directing an auxiliary brain sounds incredibly complex. What methodologies exist to help listeners, understand and classify these new communication techniques?
We can classify them along a few key dimensions, which helps clarify the specific skill required. The first is classification by example quantity.
Give us the breakdown.
First, you have zero-shot prompting. This is the simplest approach. You rely purely on the model's vast pre-trained knowledge without giving it any examples. You just say, summarize this article. It's simple, fast, but less reliable when the task requires specialized output, specific formatting, or complex logic.
Right, it might not get the nuances. And what improves reliability?
That brings us to few-shot prompting. Here, you provide a limited number of input-output examples before asking the final question. For instance, you provide 2 examples of complex sales emails and the summary format you desire, and then you ask it to summarize the third. This sets a clear pattern, dramatically improving performance for specialized tasks because you are modeling the precise behavior you want the AI to adopt.
So you are essentially training it in real time, just enough to set the context and tone. That makes perfect sense. What about how the model reasons? That seems important too.
That's the second crucial dimension, classification by reasoning approach. Beyond a simple direct prompt, the most powerful recent development is chain of thought prompting.
Chain of thought.
Okay. Instead of just asking for the final answer to a complex, multi-step logical problem, you guide the model through intermediate reasoning steps.
How does that fundamentally change the model's output? Is it just making it explain itself?
It's more than explaining. It mirrors human metacognition, asking the model to show its work. By explicitly breaking down a complex logical or mathematical problem into smaller sequential segments, step 1, step 2, conclusion code significantly improves accuracy and dramatically reduces the chance of the AI hallucinating or generating a logical error in the final output.
I see.
It forces the model to use intermediate tokens for reasoning, making its logical path more transparent and robust. This technique often takes models from, frankly, guessing the right answer to actually calculating it correctly.
So we've moved from simply asking a question to carefully structuring the entire thought process the AI needs to follow, and we're already seeing AI systems develop methods to automate the creation of these effective prompts.
Yes, that's the cutting edge, generation methods. We're moving beyond manual prompt refinement into highly sophisticated automated techniques. For example, AutoCode builds on chain of thought by automating the generation of those reasoning examples through clustering similar questions. Instead of the human having to manually structure 20 complex examples, the system can generate its own high-quality instructional data.
Wait. So one AI is generating optimized prompts for another AI.
Precisely. Even more advanced is the automatic prompt engineer, or APE, technique. This involves using one LLM, which we call the generator, to iteratively generate, test, and optimize the prompts given to another target LLM. This process can uncover highly effective, nuanced instructions that humans might never have devised manually.
Wow.
Proving that the skill of prompt mastery is so important that it is already being automated itself.
It confirms the idea that we're moving completely from execution to strategy and direction. We are defining the scope, the constraints, and the strategy, not typing the code or drafting the whole report. I think the paralegal anecdote really drives home how mastering advanced prompting manifests in complex, data-intensive roles, making this abstract concept relatable.
It shows the transition from treating the AI as a dumb database to treating it as a brilliant but structure-dependent assistant.
Exactly. Let's look at the work of someone like Priya, a paralegal in Mumbai. For a decade, her job during litigation discovery was a grueling manual task, reading tens of thousands of documents, emails, and contracts, looking for specific keywords or subtle patterns. It was high stakes, but mind-numbingly routine.
The epitome of cognitive drudgery, really.
When her law firm adopted a new AI system, her job description changed overnight. Her initial attempts to use the system were frustrating. She'd ask the AI, find documents related to the contract breach, and get thousands of useless results, just like a bad Google search. Her breakthrough came when she stopped treating the AI like a search engine and started treating it like a strategic assistant requiring explicit, multi-criteria instructions. She had to master this new meta skill.
And what did that mastery look like in practice for Priya? What kind of prompts was she using?
She learned to write and execute commands that went far beyond keyword searches. She would input a command that demanded sequential analysis and cross-referencing, analyze all communications between these four key employees from Jan 1 to March 31. Flag any emails that mention Project Titan A&D, also carry a concerned or urgent sentiment, and then cross-reference the timestamps of those flagged emails with physical building access logs for that date range.
That is the crucial difference. She's no longer just looking for data. She's orchestrating data synthesis across multiple modalities and applying human context, the concerned sentiment, to structure the search. That's sophisticated.
Exactly. Priya's story perfectly demonstrates the transition. She's not a programmer, but she is, in effect, a system pilot. She's not just finding information, she's curating the AI's output, critically evaluating its suggestions, and directing its focus based on a strategic legal hypothesis. She went from being a document reviewer to a data strategist.
That transformation captures the essence of the new meta skills. Priya stopped being an executor and became an architect of analysis. She is defining the highly nuanced parameters of success, the emotional context, the specific date ranges, the required cross-referencing. This highlights the primary pitfall of the new cognitive era, the failure to provide clear, strategic, and often complex instructions. Even the most powerful AI will deliver poor outcomes if the human operator lacks the clarity and precision to direct its effort. The value has shifted entirely to the human's ability to articulate the strategic problem.
So the ultimate dividend of automating all that routine cognitive work, the contract review, the complex document scanning, the initial code drafting, is reclaimed time. That time is now available for the highest value human effort. We talk about productivity gains, but what about the human capacity gains? What does this free us up to do?
This is where we see the most profound benefit. The liberation of human cognitive capacity for empathy, strategic judgment, and non-routine problem-solving, the non-automatable aspects of work. The AI handles the workflow, freeing the human mind to focus on connection and high-stakes ethical judgment.
I heard a story about a primary care physician in Chicago, Dr. Ramirez. She is an excellent doctor, but like so many medical professionals, she was burning out from documentation. She used to joke that she spent more time looking at her computer screen, typing up patient notes, and filling out insurance forms than she spent looking her patients in the eye.
The clinical workflow and administrative burden is a prime example of cognitive drudgery that drains human resources. It's a huge problem in healthcare.
Her clinic then implemented an AI-driven scribe service that listened to her patient conversations, synthesized the key clinical details, and automatically drafted all the notes and forms. This optimized hours of her routine tasks every week. The real story, though, is what she did with that reclaimed mental and temporal capacity.
Okay, tell us.
An elderly patient, Frank, came in for a routine checkup. Because the AI was handling the note-taking, Dr. Ramirez was just present, fully present. She wasn't rushing or splitting her attention between the patient and the keyboard. She noticed Frank seemed unusually quiet and slightly withdrawn, subtle behavioral cues that she might have missed had she been cognitively distracted by documentation.
Oh.
She used the extra time to engage with him directly, asking, "Frank, you seem down. How are things really going at home?"
She applied empathy and critical judgment to a problem that went far beyond the physical symptoms recorded on the chart.
Exactly. The AI handled the data processing, freeing Dr. Ramirez's mind to focus entirely on the human interaction. She was able to apply her unique attributes, her empathy, her critical judgment, and her strategic thinking to diagnose not just a physical ailment, but a complex problem of loneliness and depression, which no algorithm could have spotted. The AI optimizes routine tasks, allowing human professionals to focus on the unique, high-stakes, and non-automatable aspects of their jobs.
Dr. Ramirez's experience is a powerful demonstration of augmentation in practice. By taking over the clinical documentation, the AI liberated her mental and emotional capacity, allowing her to deploy her judgment to notice subtle behavioral cues. That ability to be fully present and apply complex ethical judgment is what distinguishes high-stakes knowledge work, and AI is maximizing the time available for it. This shows that AI's greatest value might not be in efficiency, but in rehumanizing certain professions.
That is the highest expression of the potential of this cognitive revolution. But there is a huge psychological fear that accompanies this shift. The feeling that if the machine can do 94% of the work, what am I for? Did AI fundamentally damage professional identity or autonomy, as many widely feared it would? What does the research say?
That question is critical, because if professionals feel de-skilled or disempowered, they will resist integration and sabotage the benefits of augmentation. There was a recent quantitative study of 150 professionals in knowledge-intensive sectors, human resources, marketing, and finance in Morocco. They were specifically looking to test the hypotheses that AI usage would reduce perceived autonomy and skill utilization and increase identity threat.
Okay, so what did the empirical findings show about the great deskilling? Was the fear justified by the data?
Well, the results were surprisingly reassuring, running counter to the popular narrative of impending displacement. Statistical analysis found that AI use was not a significant predictor of reduced perceived autonomy.
Really? Not at all.
Not significantly. Furthermore, it did not significantly influence reduced skill utilization. The anticipated widespread de-skilling of the existing role was not empirically supported by this data.
Why do you think that is? If the AI is doing 94% of the work in some cases, why isn't the professional feeling less in control or less skilled?
The key seems to lie in which tasks the AI is taking over. The AI is generally taking over the high-volume, repetitive, or data-intensive tasks that were already low autonomy or high drudgery for the human.
Stuff nobody really wanted to do anyway.
Pretty much. By removing those boring, error-prone tasks, the human is free to focus on the remaining high-stakes, non-routine tasks, the decisions, the client interactions, the strategic direction, where their skill and judgment are truly exercised. Therefore, they feel more, not less, essential and in control. This strongly suggests a successful model of human-machine augmentation, where the AI acts as a support mechanism, not a replacement.
That's a fascinating analytical payoff. It's not that the job is gone. It's that the job has been refined to its highest value human components. The boring parts are automated away.
Exactly. However, the study did observe moderate levels of identity threat.
There's the latent tension. So they still feel secure in their current job, maybe, but insecure about the future definition of expertise.
That's the interpretation. Even if the current tasks aren't de-skilled, there's a moderate psychological tension, an insecurity about the long-term blurring of traditional expertise, especially for those whose knowledge shields centered on manual execution or specific technical skills now automatable.
Right.
The conclusion drawn from this research is the reality of the emerging hybrid professional identity. The worker as an orchestrator, co-author, and supervisor of algorithmic output. The professional value lies in their ability to contextualize and direct the output, not necessarily in their ability to manually generate from scratch anymore.
So we're not just surviving the cognitive revolution, we're actively redefining what it means to be a professional in it, trading years of manual experience perhaps for strategic prompt literacy and critical oversight.
That is the choice that now faces every knowledge worker, really.
This deep dive shows us that the cognitive revolution presents a profound individual and organizational choice. AI has undeniably generated immense productivity by augmenting our intellect, much like writing and printing amplified our knowledge in earlier eras. But the choice of how we apply that power, well, that's entirely ours.
That choice means we must consciously avoid what is often called the Turing trap, the economic pitfall of designing AI merely to imitate and replace humans, thereby driving productivity gains that only benefit capital owners while eroding the value of workers. This strategy must instead be focused entirely on augmentation, which empowers workers, creates more total value, and expands the total frontier of economic and intellectual possibilities.
Makes sense.
We have built what can be described as an auxiliary brain that is fully capable of carrying the cognitive load of drudgery and routine analysis. Successful integration, and whether the benefits of this revolution are broadly shared, depends on conscious societal and organizational choices we make right now. The path forward seems clear. By anchoring our strategy in human-centered collaboration, redesigning roles to demand advanced prompt literacy and critical thinking, and viewing AI as a partner in thought, we can harness its power not just for cost-cutting, but for expanding the very frontier of human intellectual capacity itself.